Section 7.4.15-T. Compute P of x using a binomial probability formula, then determine whether the normal distribution can be used to estimate this probability. If so, approximate the probability of x using the normal distribution and compare the result with the exact probability. Okay, so what we're going to do is we're going to use the following formula. So remember that the formula is n, so it's the combination of n x times p to the x times 1 minus p to the exponent of n minus x. So if we want to find the probability of 25, then that's going to equal the following. We know that we have 60 combination of x, which is 25, times the probability, which is 0.4 to the power of 25, times 1 minus 0.4 to the power of 60 minus 25. Okay, so let's use the calculator to find this out. So we're going to take 60, and then we're going to go to Math, and then go to Probability, and then select number 3 for the combination. And then put in the number 25, and then select Enter. Then we're going to take that number and then multiply it by 0.4 to the 25th power. So we're going to take that, the answer, just times 0.4 to the power of 25. Then we're going to take this number and multiply it by, in parentheses, we got 1 minus 0.4. And then we're raising it and putting that in parentheses to the power of 60 minus 25. Close the parentheses. And then we get the following. So let's go ahead and copy that here. So if we round up to 4 decimal places, then we get 0.1005. So the first part, what we did is we used the binomial probability formula. Okay, now what we want to do is we want to use the normal distribution to approximate. So the first thing we need to do, okay, by using the approximate, so we're just going to abbreviate that, approximate using normal distribution. So the first thing is we need to check whether the probability is coming from a normal distribution. So recall that we need to check that n times p times 1 minus p must be greater than or equal to 10. So we know that n is 60. We're going to multiply that by p, which is 0.4, times 1 minus 0.4. We want to know if that's going to be greater than or equal to 10. Well, that gives us 14.4 and is greater than or equal to 10. So we can say that since it's greater than or equal to 10, that the normal distribution can be used to approximate the probability. Now, number 2, what we want to do is we want to be able to find the mean and the standard deviation. So in order to find the mean of the approximation, it's going to be n times p. So the mean is going to equal 60 times 0.4. So the mean is going to equal 24. And the standard deviation is going to equal NP times 1 minus P. So we have the square root of 60 times 0.4 times 1 minus 0.4. And so taking the square root of that number gives us approximately 3.79 as the standard deviation. Okay, now the question again is asking us to find the exact probability here and comparing it with the normal distribution where x is equal to 25. So what we're doing is now we're finding the exact. So we're looking for the probability of when x is equal to 25. Okay, so when it's equal to 25, then what that means is we're trying to find the probability that x is going to be in between 24.5 and 25.5, which means we need to find the z-scores. So recall that if we draw this bell curve, we know that our mean that's given in our problem from here is 24. And we're looking for the area that's associated between 24.5 and 25.5. So now what we're going to do is we're going to find our z-scores. So the first one, z1, we're going to take 24.5 and subtract 24 and divide that by the standard deviation. So z1 is going to equal approximately 0.13. And then we're going to find the second z-score, which is going to be equal to 25.5 minus 24. I'm going to divide that by the standard deviation of 3.79. So therefore z2 rounded to 2 decimal places is 0.40. Okay, so if we now take a look at the graph here, we have now converted it to a normal distribution where we have 0 as the mean. And now our first z-score is now 0.13, and our second z-score is 0.40, and we want to find the area that's in between there. So what we're trying to do is we're trying to find the probability now with the z-scores that the value of the z-score is going to be in between 0.13 and 0.40. Okay, so what does that equal? That equals that the probability of z being less than 0.40, and we're going to subtract the probability of z being less than 0.13 to find the value in between. So if we take a look at the area of 0.40, so if we look at 0.40, we can see that 0.40 gives us an area of 0.6554, and then the area of 0.13 is 0.5517, so let's go ahead and write that out here. So we have 0.6554 minus 0.5517, which gives us a probability of 0.1037. Okay, and then if we wanted to use the calculator to find the area that's in between those two, we would go to second distribution, and then we'll go to normal CDF. We're going to put in the lower bound of 0.13, the upper bound of 0.40 with the mean of 0 and a standard deviation of 1. And then we're going to calculate that, and then we should get the same area there. And if we wanted to use stat crunch by using the calculator option, going to normal distribution. Okay, so we know that it's going to be in between two values. We know the mean is 0, the standard deviation is 1. We know it's going to be in between 0.13 and 0.40. And then we're going to select compute there, and then we should get the same area and the same graph that we have. So therefore there is our graph using StatCrunch. And so now we want to be able to compare when we use the binomial distribution formula and what we just did. Okay, so if we compare the binomial probability that we got, which was 0.1005 or 10.05%, and the approximated probability using a normal distribution of 0.1037 or 10.37%, the probabilities calculated by the two methods differ by 0.0032 or 0.32%.